All right, that's plenty of background. Now let's get into implementation of deep learning for NLP techniques. In section 1.2 of my prequel live lessons, Deep Learning with TensorFlow, we went over step-by-step instructions for building deep learning models in TensorFlow from the ease and interactivity of Jupyter notebooks, and where all of the necessary dependencies are handled by running everything from within a Docker container. If you don't have TensorFlow set up as you like it on your machine, and if you haven't already done that installation, I'd recommend checking out that video or navigating to the installation page, which I'll show you to right now. So on the main page for these live lessons in GitHub, there is a summary of all of the previous live lessons as well as these current ones. And at the top, we have a link through to the installation directory. There are installation instructions in here for macOS, for Unix in a variety of circumstances, including where you already have the dependencies. In that case, it's a very easy git clone. If you're missing some dependencies, then you need Docker, and then you can follow the instructions for Mac. And I also have some rough notes for setting up a fresh cloud instance, if that's the kind of thing that you're interested in. There are also instructions here for Windows. And at the bottom, I give a little blurb on GPU considerations. So let's talk a little bit more about that. In the previous live lessons, we didn't talk about a GPU or a graphics processing unit at all. Originally intended for high-intensity graphics applications like video games and editing video footage, GPUs conveniently enable the parallelization of the many matrix algebra operations that you carry out whenever you train a deep learning model. The speed up that you would experience by leveraging a GPU on top of the CPUs you're already using depends on a number of factors. It depends on the particulars of the network architecture that you're training. It depends on how fast your CPUs are and your GPU is. And it depends on how much information needs to be passed between the CPUs and the GPU, and how quickly this information can be passed by your motherboard. For example, by how many PCIe lanes your motherboard has. As a general rule of thumb, however, you can expect the addition of a GPU to your machine to speed up model training by 5 to 10 times. This means that a model you used to train for a week might train in a day. A model that you train for a day could train in a few hours, and so on. By training more quickly with a GPU, you can experiment with more network architectures, and you can play around with tuning your hyperparameters more frequently, leading you to ultimately better performing models. That said, I've kept the data sets and the model architectures in these live lessons relatively small, so that we can learn quickly, and a GPU is absolutely not necessary. If, however, you would like to harness the power of a GPU, be it for these live lessons or your own projects, I've created an installation process for running TensorFlow from the convenience of Jupyter notebooks, all running tidily within a Docker container that contains all the dependencies for these live lessons. Let's go have a look at that process now. So from that installation page that I already navigated you to, there are some GPU-specific instructions at the bottom for Windows or Unix-like systems. Let's click through, since we are using a combo of a Mac and Unix here. So the first step is to, depending on what kind of machine you're working with, install an NVIDIA GPU on your machine, or spin up a cloud instance that includes one. That would typically be a Tesla K80 NVIDIA GPU. And once you have that, you need to install the CUDA and cuDNN libraries that are particular to your given machine. I won't go into the details of doing that because it's so machine specific, but I link through to a blog post that provides more information. This step might be a little tricky if you're relatively new to working with the Unix command line. Then we go through the same steps as we did for the regular install. So you open up a terminal application, and then you can head to the home directory on your machine. So cd to the home directory. You can git clone, just as we did previously. So you can copy and paste this line over. I already have these running, so it won't be necessary for me to do that again. But you can clone all of the information in this Git repository to your machine. Then you need to install the Docker stable channel and start Docker, of course. Back in the terminal, you need to source a couple of different things. So there's the regular script that I wrote here for giving permissions to access your files and write them from within a Docker container. In addition, there's an additional script here for a couple of extra permissions. And then you can move into the TensorFlow Live Lessons directory. And previously, we were using a sudo docker build command and specifying the name of the stack that we were building. This time is similar, except that instead of installing the default Docker file, we'll build the dockerfile.gpu. So we need to specify that with the -f flag, and then we'll give it a different name that calls attention to the fact that we're going to have a GPU involved. Let's take a quick look over at that NVIDIA GPU. So we'll head back to the main directory here and have a look at this Docker file. So it starts off with a kind of base operating system that takes advantage of the NVIDIA and the CUDA and CUDNN libraries. Then we have some simple commands here for getting your environment set up, like English language, and some simple or absolutely necessary packages for your system. And then we go through a series of commands provided by the folks at Jupyter for running Jupyter notebooks from your machine. So together, these install all of the dependencies you need, like the Miniconda environment for Python 3, Jupyter notebooks, Jupyter Hub, and it also installs, these essential kind of tools: Emacs, Git, Vim, and of course, also Python 3 specific packages that we will need. So the SciPy package, Matplotlib will be making use of in these live lessons, as well as pandas. You're probably familiar with many of these packages. And then at the end of the file are some lines that I added in, which involve installing TensorFlow specifically for use with a GPU, a couple of the high-level TensorFlow APIs like tflearn and Keras, which we'll be working with heavily in these live lessons, and then also some natural language processing specific packages. So the Natural Language Toolkit and GenSim are additional libraries that you will need for these live lessons. All right, let's head back to that installation page. There's only one step left, and this is quite similar to step 9 in the earlier instructions. The only difference is that we're using the NVIDIA wrapper around Docker this time. And of course, we need to specify the name that we specified here to make sure we're running the GPU stack. So once you've run this final command and your Docker container is running, you can head back over into your terminal session to make sure that everything is running well and that you are in fact connected to the GPU. So you can type in sudo docker ps to see what Docker containers you have running. And I know that the image I'm looking for is this guy, because that's what I specified in that final line that we talked about running in the install. And I know that I named it Bald John. If you didn't specify a name specifically, it will have assigned a random name. And then you can enter into the container by specifying that name with that command. So now we're inside the container, and we can make sure that we're connected to our NVIDIA GPU by typing NVIDIA-SMI. And here we can see that although we're not using the GPU right now, it is available to us. This is a very good sign. Great. So whatever hardware you're using, we're now set to build models in TensorFlow. Up next, we'll review essential deep learning theory as a jumping off point for the NLP-specific deep learning theory and applications we'll cover throughout the rest of these live lessons.